Sequences and summation notation. A sequence is a list of numbers that follow a pattern. Each term of the sequence is noted by a sub n, where a sub 1 would equal the first term, a sub 2 would equal the second term, and so on. In this first example, we're asked to write the first 4 terms in the sequence. So we have the pattern given to us in the formula, a sub n equals negative 1 to the power of n plus 1 times n squared. So we start by, for the first term, replacing the n with 1. That indicates the first term, and since n is 1, everywhere in the formula I see an n, I replace it with a 1. So negative 1 to the power of 1 plus 1 times 1 squared, which would be negative 1 squared, and then 1 squared is just 1. Negative 1 squared is positive 1, so 1 times 1, and it's 1 for the first term. Then a sub 2, second term. Everywhere we see an n, we'll put a 2. Negative 1 to the power of 2 plus 1 times 2 squared would be negative 1 cubed times 4, which would be negative 1 times 4, negative 4. The third term, a sub 3, everywhere we see an n, we replace it with a 3. Negative 1 to the power of 3 plus 1 times 3 squared would be negative 1 to the 4th times 9, which is positive 1 times 9, which is 9. Anytime you have a negative to an even power, it becomes positive. If you have a negative to an odd power, it becomes negative. And then the last one, the fourth term, a sub 4, everywhere we see an n, we'll replace it with a 4. Negative 1 to the power of 4 plus 1 times 4 squared would be negative 1 to the 5th power times 16. Negative 1 times 16 is negative 16. This one's a little bit different. Again, we're asked to write the first 4 terms of the sequence, and we're given the first term. Then we have a formula to follow for the second term and beyond. But the second term will require going back to the first term. Every term will require going back to the previous one because of this little n minus 1. That's the previous term. So formulas like this are called recursion formulas. You have to go backwards a little bit each time. Our first term is 12. We want the first 4 terms, so we have the first given to us. Then the second term, a sub 2. So everywhere we see an n in the formula, we'll replace it with a 2. Following the formula then, it would equal a sub 2 minus 1 plus 5. 2 minus 1 is 1, so a sub 1 plus 5. And we were given a sub 1, it's 12. So 12 plus 5 is 17. Now we need to find the third term, a sub 3. So everywhere we see an n, we'll replace it with a 3. A sub 3 minus 1 plus 5 would be a sub 2 plus 5. And we found a sub 2 to be 17. So you go back 1 and pick up the previous term to put in the new formula. 17 plus 5 is 22. And then one more, a sub 4 would be a sub 4 minus 1 plus 5, which is a sub 3 plus 5. We found a 3 right above, it's 22. So 22 plus 5 is 27. So when you have to go back and get a previous result, that's called recursion. Some formulas in this type of math we're doing is called discrete math, require us to multiply consecutive integers, such as 5 times 4 times 3 times 2 times 1, or 7 times 6 times 5 times 4 times 3 times 2 times 1. The shorthand notation for this type of operation is called a factorial. And so for the one that starts at 5, you could write that as 5 factorial, which is represented by an exclamation mark. 5 factorial means 5 times 4 times 3 times 2 times 1. So then the other one that starts at 7 and goes down would be 7 factorial. So it's a shortcut notation so that we know that if we see that, we need to multiply by consecutive integers going down. So these problems say evaluate each factorial expression. And I have 18 factorial over 16 factorial. So we're going from 18 down to 1, multiplying consecutive integers. And after you've practiced a while with these, you can kind of figure out some of your own little shortcuts so you wouldn't necessarily have to write all this out. So there's 18 factorial over 16 factorial. So from 16 on down. And then you can cancel out top and bottom from 16 on down. And all you're really left with is 18 times 17, which is 306. The next one, 10 factorial over 3 factorial, 7 factorial. There are several types of formulas that use these factorials, and a lot of times the formulas are set up like this. So 10 factorial, we're going from 10 on down. Over, and then 3 factorial, 3, 2, 1, times 7 factorial. So 7 on down. And then we can cancel top and bottom. I can cancel from 7 on down. And then I can divide 2 into 8, leaving 4. I could have also done 2 into 10. Doesn't matter. I can cancel 3 into the 9, leaving a 3. So what you really end up with is 10 times 3 times 4, which is 120. Okay. When we want to add several numbers that follow a pattern, but we want a shorter way to indicate this, we use summation or sigma notation. It uses the Greek letter sigma, which is this E type thing. And then the bottom tells you where you're going to start, and the top tells you where you're going to stop. And then you'll have some sort of formula written beside the sigma. Sigma means sum in math. So if I want to find the sum, I have my formula is 2k, and k is supposed to start at 1 and stop at 5, and you'll go every number in between. So k will be 1, then 2, then 3, then 4, then 5, and you add each time. So what that's going to look like is when I start with k equals 1, it would be 2 times 1, then it's a plus, and then k changes to 2, 2 times 2, plus k goes to 3, and then k goes to 4, and then finally, because the top number is 5, we stop at 5. And then that would be 2 plus 4 plus 6 plus 8 plus 10, which is 30. Sometimes instead of a k, they might have an I. Really, you could use any letter for that variable. This time we have the sum from I equals 1 to 4 of negative 1 to the power of I. So we start with I being 1, negative 1 to the first, and then you add, I changes to 2, negative 1 squared, plus I changes to 3, negative 1 cubed, and then I finishes at 4. So it's going to be negative 1, plus 1, minus 1, plus 1, which is 0.